This video is about what I call the guess-check method for integration. It's sometimes called integration by inspection, more formally, or spotting the derivative. And sometimes it's called finding the antiderivative, because integration is the opposite of differentiation. So it is almost like saying the question, what differentiates to give? So really simply, if I'm integrating 2x, I'm thinking of that as, well, what differentiates to give 2x? I know that x squared differentiates to give 2x. So the antiderivative of 2x is x squared, and that's my answer. Now that's obviously a really simple example. Let's try some slightly more complicated ones with my guess-check method. So we are looking to integrate each of these things. We could do so with substitution, like we've seen previously, but I want to try to do this in a quicker way, if I can. Now, each of these things I can do with the guess-check method because, really importantly, I have a derivative. What I mean by that is I'm looking at this, thinking about what's the complicated part of it. So in the first example, I'm looking at the x squared plus 5 inside that bracket. And so I'm thinking, what does that differentiate to give? And that differentiates to 2x. The x squared differentiates to be 2x, the 5 would differentiate to be 0. And because it differentiates to be 2x, that's kind of similar to what I've got at the front there. So I think the guess-check method might work here. Similarly with the second example, I'm looking at what's on the bottom here, and I'm thinking about what does that differentiate to? The 3 would disappear. The 2 sine x would differentiate to be 2 cos x, which is kind of similar to what I've got on the top. So again, I think the guess-check method might work. And with the third example, if I differentiate the denominator here, I would get 6x, which again, similar to what I've got on the top there. So again, the guess-check method might work with that one. If I had a plus 1 on the top, my guess-check method would not work because the 3x squared would differentiate to be 6x, which is very different to the x plus 1. That plus 1 changes everything. So, the guess-check method will work when you can see something that kind of looks like it's got a derivative involved. If you can spot that, the guess-check method looks like this. Really simply, we're going to guess what we think the answer might be. So in this first case, I can see I've got the x squared plus 5 to the power 3 at the moment. So I'm going to guess that when I integrate that, I'm going to guess that my answer is x squared plus 5 to the power 4. I'm just going to add 1 to the power, because that's usually what happens when we integrate, when we have a power, plus my constant, of course. Right, let's check. Does that work? If it does work, if I have managed to magically guess this perfectly on the first go, then when I differentiate it, I should get back to the integral I started with. Well, let's see. Let's differentiate this. So first, I would multiply by the power. So I'm going to times by 4. And take 1 away from the power. And then, by the chain rule, I'd have to multiply that by the derivative of the inside, which is 2x. And then, obviously, the plus c would differentiate to be 0. Right, the 4x times the 4 times the 2x is 8x. Right, so according to my guess, I've guessed this is my answer, but when that differentiated to give something that was 8 times bigger than it should have been. So, that's telling me now that I should divide my guess by 8. If I divide my guess by 8, that would also divide my answer by 8, which would then give me the integral that we started with. And so that's my answer. Next example. So I've already identified that we've got a derivative, so this guess check method might work. Now in this case, I can see we've got a fraction here, so I'm thinking this might be with a logarithm, especially considering that there's no power on the denominator. So my guess is going to be ln 3 plus 2 sine x plus c. Let's check, does that work? Let's differentiate it. So differentiating the logarithm gives me 1 over. And then by the chain rule, I would have to multiply that 1 on the top by the derivative of the denominator. The 3 differentiates to be 0, and the 2 sine x would differentiate to be 2 cos x. So that's just going to simplify to be 2 cos x, 2 cos x over the 3 plus 2 sine x. Now, compare that to the original question. The original question had a 4 here instead of a 2. So it was 2 times bigger. So actually, what I need to do is multiply my guess by 2 so that I get the correct answer. And there we go. Next example. Again, we've already checked, we've looked for that derivative. We know that this differentiates to be 6x, which looks similar to what we've got on the top. So, the guess check method will work, hopefully. I'm going to guess. Again, we've got a fraction here with a single term here on the bottom. So I'm thinking it might be a logarithm. So I'm going to guess ln 3x squared plus 5 plus c. Right, let's check. Does that work? So let's differentiate it. If I differentiate the logarithm, I get 1 over. Then I have to multiply that by the derivative of the inside. So differentiate 3x squared plus 5, and I get 6x. Right, compare that to the original integral, and I've got something that's 6 times bigger than it should have been. So that's telling me I need to divide by 6. And that is my answer. 1/6 ln 3x squared plus 5 plus c. So we're going to do 3 more examples, then we're going to have a look at an exam question. Okay, example 4. Could we use the guess check method for this? I'm looking at the x squared plus 4 on the denominator there, and I know that differentiates to be 2x, which is similar to what I've got on the top there. So I think the guess check method might work. So what are we going to guess? Well, looking at the denominator there, we've got a power 3 on the denominator. Now, the way we usually integrate those is we put it to the top with a negative power. So, that way, I'm going to guess that adding 1 to the power would be like that. Right, let's check. What does that differentiate to give? So multiply by the power, so multiply by minus 2. Take 1 away from the power. Then we'd have to multiply by the derivative of the inside, which is 2x. So that would give me minus 4x over x times x squared plus 4 to the power minus 3, which is the same thing as minus 4x over the x squared plus 4 all cubed. Right, comparing that to the original question, and we can see it's more or less exactly the same. The only extra thing I need is a negative, because when my guess produced a minus 4x over x squared plus 4 to the power 3, whereas it should have been a positive. So if I put a minus here, this will now be the correct integral. Next, we've got the integral of 3 cos x times sine squared. Now, I'm looking at the sine squared here. That seems to be the important part. Now, sine squared, remember, is the same thing as just sine x squared, like that. It means exactly the same thing. And I know the derivative of sine is cos. So yeah, I think we can use the guess check method. My guess is going to be, right, add 1 to the power. Add 1 to the power. So we'll get sine x all cubed. And let's differentiate this and see how close we get. Right, so we're going to times by 3. We're going to take 1 away from the power. And then, by the chain rule, we have to multiply by the derivative of the inside, which is cos. Sine differentiates to be cos. Rearranging, so we get 3. I'm going to put the cos at the front because it doesn't have a power, or rather its power is just 1. The sine squared is the same thing as this. And look, in this case, actually, my guess was exactly spot on. I don't need to adjust this one at all. The only thing I might do is write sine cubed rather than sine x cubed. So I might put the 3 here instead. But otherwise, I got pretty lucky with that guess. Next example, we've got x e to the x squared. So I'm looking at the e, that's the important part here, and the inside of that is x squared, which I know differentiates to be 2x, which is similar to what I've got at the front. So I think guess check might work. My guess, well, the exponential, I know would integrate to be the exponential, so let's just check that. E to the x squared. Let's see, would that work? If I differentiate the exponential, I get the exponential, nothing changes. But by the chain rule, I have to multiply that by the derivative of the inside. The derivative of x squared is 2x. Right, compare that to what we started with. It's 2 times too big. Therefore, I need to divide my answer by 2 to make sure I get the correct answer overall. And there we go. This is the guess check method. It only works when you have a derivative involved, but it can save you a lot of time. Let me show you an exam question from a few years ago. Now this was the first part, no, it wasn't the first part. This was a part of an exam question. It was only worth 3 marks. And if you were going to do this the long way with substitution, it can take a long time. If we do it with the guess check method, it's nice and quick and simple. So, ignore the limits for now, that was for a different part of the question. Let's just do the integral. So, I'm looking at this part first. In particular, I'm looking at the cos, because I know that cos differentiates to be minus sine, which is kind of similar to what we've got at the front there. So I'm going to guess that that's going to integrate to be cos cubed theta. I've just added 1 to the power there. Right, let's check. Right, differentiating that, I would get 3 cos squared theta multiplied by the derivative of the inside, which is minus sine theta. So I'd get minus 3 sine theta cos squared theta. Compare that to the original, compare this, and we can see it's nearly there. It's just 3 times too big, and we've got a minus. So let's divide it by 3 and put a minus at the front. And now we know that this is the integral of this. Right, let's now move to the next, which will be this. We'll focus on that and then we'll worry about the negative in a minute. So for this second one, again, I'm looking at the cos, and I know it differentiates to be minus sine, so the guess check method is going to work here. I'm going to add 1 to the power, so I'll get cos to the power 5. We're going to check that. So differentiating the cos to the power 5, we'll get 5 cos to the power 4 multiplied by the derivative of the inside, which is minus sine. Simplifying that, I'll get minus 5 sine, sorry, that should have been a theta, not an x. Cos to the power 4. Comparing that to what we started with, and you can see that it is 5 times too big, and we've got a minus. So I need to divide my guess by 5 and put a minus. And now I know that that green box there is integrated to be the minus 1/5 cos theta to the power 5. So putting all of that together then. The first term in yellow integrates to be the minus 1/3 cos cubed theta. The second term in the green box there integrated to be minus 1/5 cos theta to the power 5. And then not forgetting that we had this minus in the middle, which is actually going to take these two and turn it into a positive. And there we go. In this case here, I would carry on this question, putting the limits in. And that would be the continuation of this question. But the key thing that I want to get across here is the idea is the guess check method. When you have a derivative of a function that's also involved in the integral, you can guess what the answer is going to be and then differentiate it to see how close you're going to get. Won't always work, but it can save you a lot of time if you want to avoid doing integration by substitution.